Well, let me continue to the next one. Up to now, we have the discrete event simulation. All right. And how about the continuous simulation? Continuous says we have a continuous time. And continuous time, then we'll have a step variable change with respect to time. And so that any time instant will be possible. If so, this one, can we apply the previous event driven? In fact, no. Because of no, so we get back to the description of the problem. So this kind of a problem. We will have a problem. A problem involves the differential equations. Therefore, we have the differential equation to describe the system we want to study. If it is a system described by the differential equation, then somehow I will want to solve the differential equation. To solve the differential equation, sometimes we will apply numerical analysis techniques, and so that we can solve the differential equation problem. To solve this kind of a problem, actually MATLAB. MATLAB is a possible tool. And if that is a possible tool, then we will have a Simulink. Alright, so for this one, actually, it's difficult, or maybe it doesn't mean it's difficult, but at least to describe the behavior, we need to solve the differential equation. Once the differential equation has been solved, then we can have the action of the system. So we don't have the code directly. Instead, we have the package for this kind of simulation. For example, MATLAB, and then you can use Simulink. Well, should we have the other possible package for simulation? Yes, actually, for the taskable, we will suggest you using Arena. And Arena allows you to have the discrete event simulation, continuous simulation, and also the combined version. Therefore, if indeed you have a simulation to have the nature of both discrete and continuous, then you can have the simulation. Well, this is the kind of simulation we study currently with the random phenomenon. Actually, if you talk about the machine learning, or maybe we talk about the reinforcement learning, then we have the discrete and continuous space as well. And so that you will have some experiment with the combination of discrete and continuous spaces. Actually, there we have a space. Same, we have some phenomena like this. About the stats, we have discrete events, discrete time stats or continuous time stats. So that we need to consider we have the whole discrete or whole continuous or combination of discrete and continuous. Here we talk about simulation, so we will care about simulation here. And of course, to take care of this kind of combination, we have a tool, Arena. For this one, machine learning or reinforcement learning, of course, you can refer to the suitable experiment, how to implement that kind of experiment. Therefore, up to now, we don't know discrete event simulation, but about the continuous one, we don't know we need to solve the differential equation. However, we mentioned that one, we don't know we need to apply the numerical analysis techniques to solve the differential equation. And here, this one, the final one, the combination of discrete and continuous simulation, then you can have the package arena to help you. Well, finally, this is a definition, Monte Carlo. So Monte Carlo simulation, it is a simulation based on this kind of concept. If it is a Monte Carlo simulation, Monte Carlo needs to employ the random number. Any simulation employ this one, then we call it a Monte Carlo simulation. For this one, Monte Carlo simulation, normally we don't mention about the other, so we should call this is a static simulation rather than dynamic simulation, because it follows fixed one, and then we don't have the random seeds. If we don't change random seeds, then we will have the static behavior rather than the dynamic behavior. So this one, Monte Carlo simulation, actually, we don't have the simulation, and the just simulation. And this kind of simulation, we always have in fact, the same pattern. Or maybe the fixed pattern. I don't call it the same pattern, a fixed pattern. Alright, a fixed pattern. Because of the fixed pattern, then we have the static simulation rather than the dynamic simulation. If we don't have the random seeds to alter the simulation, well, so this is a fundamental one, Monte Carlo simulation. If we have the random number u of 0 and 1, based on this to have the simulation, then we have the Monte Carlo simulation. And once you have the program, actually we have the Monte Carlo simulation for our MN1. If for our MN1, actually we have the fixed one. If we don't have the random seed, so if we have the random seed, we can run simulation. For number 1, number 2, if we have the random seed, to restart the simulation, to, for example, to number n simulation, so that we will have a result, for example, 1.5 for the first simulation run, 1.6 for the second, for example, 2.0. Well, so for all of them, they have the simulation for the same system. But how to have the final result, we will have the average again. And here we assume we have 10 simulation run. And then we have an average. And this average have the final aspect of some performance measure. For this one, actually we have multiple one, and then we don't expect they have the identical result. In fact, we expect we have a different simulation result so that we have the dynamics. Actually, dynamics of a simulation. If we have the dynamics of a simulation, actually we still need to have one value to estimate the performance measure. We use average. If we have an average here, then possibly we will have the interval. We call confidence interval. And confidence interval, CI, will be discussed in chapter 4. So in chapter 4, we can know this kind of result based on the statistics. And statistics, then we can have the confidence interval. So we will have a way to have the confidence interval. We will have the discussion from the theoretical discussion, and then we can reach the definition for the confidence interval. Of course, we can pass on the average to have the value for different simulation runs. Well, that's it. So this is the Monte Carlo simulation, and the same allow you to have 30 seconds to think about this, and also let me have more water for drinking. All right, so because of online lecturing, so I will set timer. I will pause for a few seconds, and so that you guys can think about the concept I'm delivering to you.